All right, the lights are down. Good morning, everybody. So thank you very much for joining us. The first session of the day. I'm sure many of you are out enjoying San Francisco and a bit of pre-Paddy's Day celebrations. So I know I was working on this into the early hours, and I was also drinking a few beers, so it took me a bit to get out of bed this morning. Actually, just got a few more guys joining us, so I'll just wait a second. Right, so security and gaming. I'm just going to talk through the next 40 minutes of a company I work for and a technology that we have that's really going to help you guys protect the gaming accounts inside the applications or the services or the games that you're building. But before we do that, I think many of you are likely here because we're giving away this guy on our booth today. So this is a Forge 3D printer. Actually, it's about $800. It just came out, so it's probably one of the more advanced under $1,000 printers. And if you want it, first of all, you're here. Good start. Second thing is you want to go to this website, demo.authy.com, sign up there, and after you sign up, that's going to give me your email and phone number so I can communicate to you through the demo. And then secondly, you need to install the app on your phone, and that is the communications channel by which I will talk to your devices. And what I'm going to do is after I've gone through sort of 20, 30 minutes of slides explaining how technologies work and how 2FA works, I'm going to go into this site, modify this code, and add our technology to that site. And the first person to log into that site and go through our authentication gets the printer. Okay? And again, any Authy participants in the audience, please do not do that. I do not want to be giving this to my boss. So first of all, who am I? Why am I here? And why am I talking to you guys? So I'm actually the product owner of Authy, which is a service inside Twilio. Twilio is a cloud communications platform, and we're based here in San Francisco, but we have offices all over the globe. And to get to this point, I've worked, I started my career out in the security industry with a company called Dell, I'm sure you're familiar with. Then I went to a very small startup in England called Sealed Media, doing data encryption and email encryption. And I got acquired by Oracle. I spent 4 years at Oracle doing identity management. I moved to Microsoft, spent a couple of years there doing data security and identity management. Went to a Swiss firm and led a product encrypting data out of SAP. And then spent a year or so at Okta, which is a cloud identity management platform. So these are all kind of boring enterprise companies. And I've spent about 20 years in security and identity at these. So you might feel I'm at the wrong conference, or I'm at a games developer conference, when a lot of my experience here has come from big companies developing security and identity. So I actually started in games. So age 19, I left my rural house in Lincolnshire in England, moved to London to work for a company called Domark. It's about over 20 years ago now. I worked in a game called Champman 2, which was a very popular UK game for people who are into football or soccer if you're in the US. And I had on my desk, and I was an artist, so I designed interfaces, and I did the intro reel and stuff, and I had one of these big old Silicon Graphics workstations on my desk. So this is what I made. Great, no one's laughing. I thought there might be a little bit of a giggle at that. So that was, in its day, something I was very proud of. That was the UI I built, and I used this. Anybody know what this is? Anybody here ever used Animator Pro? Oh, one guy, okay. Right, I don't feel that old. Do you know who made this? What company built this software? EA? No? Oh boy, yeah, I do feel old. This is Autodesk. This is one of their first products. It was fantastic. It had really good palette controls. It had really good. It was designed for 8-bit images and animations. But that's where I started life. But I'm not stuck there. So I have moved on in the last 20 years. Yes, I've been working for a few security companies in that time. But now I'm a husband and I'm a father of 2. Nicholas is my 5-year-old. Jack here is my 7-year-old. And we mostly look like this. We're big gamers in the house. In fact, it's not just me and my kids that play. It's the whole family. So my wife's my father-in-law, Stephen, he's in his 60s. He's racked up more time on my Minecraft server than I have, which is amazing. I actually use Twilio. Twilio being a cloud communications platform, anybody who logs into my Minecraft server, I get a text. And the amount of times I see Stephen getting up at 6 in the morning before his wife does get a bit of Minecraft time in, which is pretty great. And cousins, and we have all sorts of friends on our server. So we're a big gaming family. So this, to me, is a great audience. I love gaming, and I love security. So this presentation I was really excited to put together and kind of bring some of my experience into your world. And I have kids playing games, so security to me is a real concern. I am very interested in how they're going to grow up into a world where their identity is online, their information online is better protected. So that's kind of how it led me to here. So gamer security. What am I talking about? Where am I starting? So if we look a little bit about the history of this, it's not been great. I mean, if I even just look back a few years, we all know about some of the challenges with Blizzard and World of Warcraft. They've been seeing an unusual increase in people trying to attack the platform. The more popular your gaming environment is, the more likely you're going to be targeted. Everybody knows about the problems that Sony's had. And it doesn't just stop at Sony. Everybody has fallen foul to some sort of attack, denial of service, some sort of infiltration, phishing attempts. It's just getting more and more sophisticated, more and more complicated, the methods by which people are trying to get essentially into your gamer accounts or into your service to extract data, take you down, do something of that nature. And I was looking for articles on this, and yesterday at 5:30 local time, another article about a malware tool that you can use with Steam that allows you to hijack accounts. So this is consistently a problem. And we do have technologies that help, but right at the core of this problem is the darn password. We hate passwords. And this, you might be laughing at this saying, he's showing me passwords that people shouldn't choose. But unfortunately, this data is the top 5 passwords from 2015. So there was a few companies that did some research. They looked at the results of breaches where people have posted all these passwords online, and they also had other ways of communicating with companies and looking at password data. And 123456 is still the top used password in consumer-based applications. And the email you'd have got when you signed up for the website demo.authie.com, I thought, you know what, do I let them choose a password? I thought, no, I'm going to set it to 123456 to make the point. So your initial account that I created for you has that horrible password. And everybody's sick of them. And the problem is these things have been around for a very, very long time. I did some research and found the first evidence I could find of a computing system that leverage a login. So usually you're authenticating to a computer if it has network access. So the first kind of network computer was MIT's CTSS back in the 60s. And if you look at the differences between a data center then with the whole tapes and, the capacity of that data center is probably on my phone now. And Google with their enormous data centers and Microsoft and all these fantastic advancements we've made in computing technology, storage, bandwidth, etc., we're still using passwords. So password is still at the core of the problem. But authentication technology hasn't just sat there doing nothing. We have fantastic things like OAuth and OpenID Connect, and I can use your Facebook authenticated account to log into my game. And that is an advancement. So we have been moving forward in authentication and in security. But unfortunately, at the core of a lot of these technologies is still a username and a password. So I'm kind of painting a very grim future here. I mean, if we're still using passwords, how are we going to get around it? What are the ways to obfuscate and get and improve that process of authentication beyond just using a password? So there is a bit of light at the end of the tunnel, and we call it two-factor authentication. So this room has got really dark, and I got big lights in my eyes. But who here is familiar with the phrase two-factor authentication? I see a raise of hands. Oh, right, brilliant. A vast majority of you, so I don't need to explain that too much. Let me just quickly go over the core tenet of what 2FA is about. So it's about something, so two-factor authentication is using two pieces of information to authenticate you to something. I know that sounds very simplistic. The first type of category of information is something that you know. And this is what we're all using right now, username and password. Your username might be something you're given, like it's your email address. It might be something you choose, Mad Hatter 1942. Your password might be something you choose, or if you think about authenticating to your bank when you call them up, they may use your mother's maiden name as part of that authentication process. Then there's something you have. So this is a physical thing. So the problem with something you know is other people can know it. People can steal it. People can be tricked into getting it. I was talking to a company in our office yesterday, a games company, who has a big problem with bullying. So they have lots of children playing their games, and they get bullied in the playground to get their information about something that they know. It's not a great mechanism. Something you have is a little bit better because I have a physical thing. And today, everybody has a phone. So we're using these devices as part of the authentication process. And if you work for a fairly large company, you might find that you need a card to get into the building. And that's just another form of authentication, and it's something that you have. And then finally, commonly called biometrics, but something that you are, a physical aspect of yourself as part of that authentication process. And Apple have done a fantastic job, and Google as well, but Apple kind of led the way with Touch ID. And it's semi-quasi-biometrics. It's not a true kind of using your identity physically as the authentication. It's actually just unlocking other information on your phone. But it's a step in the right direction. Touch ID is giving us a better way to provide some sort of authentication to applications or the device itself just by putting your finger on the button. So passwords are horrible. We do have technologies which have been helping us with this. And if we look at the history of these, way back in the 80s, even before I started work, a famous company called RSA that developed a lot of the original cryptography algorithms and mechanisms, they had something called Secure ID. So it's this little thing you carry around with you with a rotating number on it that you would use as part of your login. Then as cell phones became more ubiquitous in the 90s, we then thought, you know what, instead of having somebody carry this device, why don't we just call their phone or send them a text with the information that they need to log in with? And then finally, the hardware was translated into software, and we can now run the same stuff that was on that hardware device on your phones. So we have been making progress. And these mechanisms work today. A lot of people use them. In fact, there's a lot of value in some of the voice and SMS technologies. Why? Because I travel a lot, and I might go to Colombia. And when I get to Colombia, I will logging into systems. I don't want to switch data on my phone because they absolutely charge the heck out of you for accessing data in South America. So I switch that off, but I still have SMS. So you need to be able to fall back to these capabilities to be able to reach a user who might be in a location who is unable to get the more modern types of 2FA that I'm going to talk about in a moment. And being able to generate these tokens with a device that doesn't have network access is also very important. So whilst these are older technologies, they're still important as a complete solution, but we need to do better. And we are doing better. And if we look at some of the problems with these, again, you might recognize the Blizzard tokens here on the left. They sell you these, so it's a cost. They don't really want to sell you these. They don't really want to have to deal with these tokens and supporting users. And Steam, again, they have implemented some form of two-factor authentication, but often they're just emailing you a code, and email's not very secure, and it's a pain for the end user. You're logging into something, got to get your phone out, where's that email, you read the code, you type it back in. That user experience isn't great, and because of this, most 2FA technologies are opt-in. You say to the end user, hey, you want a secure account? Well, you could switch this thing on. It's a bit of a pain, but you can get through it, and it's going to give you a bit of extra security. So the more savvy people will probably do that, and everybody raise their hands in this room, are likely to go through that process. But again, the user experience isn't brilliant. It could be better. And it is better, and what I'm going to do is I'm just going to switch to an example of an integration I did a few months back now. Took Minecraft and Minecraft's extendable through Java, so I used our product to sort of demonstrate how we can do 2FA better in the context of a gaming environment like Minecraft. And a quick shout out to all the fantastic people on Minecraft Forge on IRC who helped me with the Minecraft side of this. So let me switch to video. Here we go. So here I've got a little video. On the right-hand side, or your left, sorry, is a Minecraft server running locally on my machine. And on the right is my phone. And what we're going to see, is as I log into that environment, I'm presented with a dialogue. And I was doing this for a demonstration, so I had all the 2FA capabilities sort of rendered to the user logging in. Typically, you're going to make this decision for them. So in a real implementation, you're not going to see something pop up and say, hey, how do you want to do your second factor? You're probably just going to call out to our service or a service and initiate the request. And that's what I do here is I click on the push button. So what push notification is very different to something like this token that's being generated. And if you look on the phone, I hit push, and my phone receives a request to say, hey, somebody's doing something, click on this button. In the same way you get somebody's retweeted your tweet, or somebody's posted to your Facebook wall, of that nature. It's exactly the same idea. You select this, and then our software, now either the app that you've installed on your phone, or an SDK that you can bundle into your applications, pops up a UI which is way better than looking at a token and typing it back in. And for the reasons for that are, first of all, you brand it. So here you would have your logo of your game. So, oh, this is coming from the game. Okay, so I have some confidence this is coming from an authoritative source. And then you put a bunch of details in there. Now, if I'm actually logging in, I'm going to ignore all this. I'm just going to go, yeah, it's me. I hit approve. And when you hit approve, what the client does is calls to our service, and our service talks to your server and say, hey, that person that's logging in just approved. And we secure this entire communication. Now, somebody approving it is pretty straightforward. Somebody denying it, let's say I'm sat in a coffee shop and I'm just sitting there and my phone beeps and I look at it and I go, now I'm going to care about the information because I'm not in front of my computer. I'm not logging onto my Minecraft server. What's going on? So I'll look at my phone. Now I want to know this information. And this is all customizable. You can put whatever you want in here. So whatever is in your game that's useful, you would render here. And if I hit deny, it's an immediate response back to the application. So whoever is trying to log in as me, you hit deny, that login stops. It's an immediate thing. So they might, oh, that's strange. Well, I've got his username and password. Try again. They can keep repeating it. Your phone's just going to keep beeping. So two things that are going on here. The end user is really informed. Someone's trying to get into my account right now, and I'm able to stop them from doing that. Also, your service that is in the middle of this channel of communication is able to go, Simon's account's been hit 10 times in the last 5 minutes, and he keeps pressing deny. That looks suspicious. And you can act on that. And whatever mechanism you may wish to employ to act, you might disable the account, you might email the end user, you might start to step up the security of what's happening in the authentication phase and do more than just this. As a Twilio company, you could also do, somebody clicks on deny, and you could actually have them make a phone call from the device via a VoIP connection through our cloud service back to maybe the help desk. So yeah, someone's trying to break in, and you can have a conversation with somebody. Of course, that would be Uber support for a gaming company, but some companies like banks, etc., would find that valuable. So let me keep this going. So you hit on approve, and again, like I said, it's an immediate callback, and then you're into the application. So we built this into Minecraft. It's an interesting way to see it inside of a game. Most people who are deploying our technology are doing it by integrating on the website. So they have a website, and you're logging into the website. But essentially what's happening here is in Minecraft, I was just calling a REST API. So as long as your game, you could be inside Unity. And if Unity gives you the capability to make a HTTPS request to a web-based RESTful endpoint, you can do this. You can have this inside a Win32 application on iOS, on Android, or on Mac or a PC. Take this one step further. So now so up until this point, we've been talking about people logging into an application. Take this further to, now I've got this way to communicate very securely with the person who has the registered device for that account, or devices. So we support multiple. You could have an iPad, you can have an iPhone and Android. We're going to communicate with those when something's happening. Now, we've been talking about login. What if it's an in-game action? So here we go. I've wound this forward a bit. Here I've got a Authy door inside Minecraft protecting my really important castle or building. And this time there's no question. There's no kind of what mechanism do you want. It's just saying, hey, you're opening a door that's secured. Whoever owns this has been notified. Now, in this scenario, it's slightly different. So you can see here how I've customized the message. Now it's saying player attempting to open secured door. But this transaction probably isn't going to the player in the game at that time. It's probably going to the person who owns the door, whoever had the mod and planted that door. So this, again, Minecraft, it's kind of a fun way to show this. But imagine if you have a trading economy system inside your game, and you hit a certain threshold. Trading maybe a 5-coin item, a 10-coin item. But somebody tries to trade a 1,000-coin item. If that's happening as part of malicious activity, so if somebody has taken over the computer or the account and that's happening, you might want to, for high-risk items, send out a notification to the person. So again, I'm sat in a coffee shop and my phone beeps. It says, hey, Bill, you are trading your very expensive gold diamond-studded sword with Jim. No, that's not me. And the real-time ability to say deny. And again, this is kind of the UI that we just provide out the box. If you take our SDK, you just get an object with properties on it. So you could do some really interesting logic. You could say, use a mobile app to communicate to them that something's going on. And instead of just approve and deny, you could take other actions like stop trading, deny trading for the next 24 hours. And Steam, I think it's Steam, or is it Blizzard? I think there's a company that has this concept of, depending on how you are using the game, depending on how you're authenticated, they will delay trades because this is a real issue. But the problem with that is the end user doesn't have very much control over it. This is putting a lot of control right in the hand of the person who cares about the item being traded to make a decision themselves. So that's kind of a little video of just some integration we did with Minecraft. And again, I was talking a little bit about use cases. So primarily, we're about stronger authentication. Why are we stronger authentication? Because username and password is horrible, and so you add something else to the process. We support SMS and voice and tokens and typing that token into the application because it's important to make sure that you support the wide variety of users that you have globally. Not everybody has a smartphone that can install an app. Again, some of the games companies I've been talking to this week are talking to children that might be using their parents' devices. So the notification you're sending may not well be to their device, it might be to a parent's device. So you have to support all the varieties of authentication to make sure that you have a good fallback. But that push-type notification is by far the best method. And if you look at Twitter, you can switch account verification on in Twitter. You get a similar thing. Yahoo have just recently built something similar themselves. So we're seeing a lot of other people starting to go in that direction. And we obviously offer it as a complete service to you. And that authentication you would apply to consumers, so your end users playing the games, logging into the sites, but also to the community in general, forums and all sorts of places where people are. Twitch TV, for example, launched with our service, I think it was late last year, and they're doing that because they want to protect their community of users, their celebrities that are using their platform to communicate. They don't want people hacking their accounts and pretending to be Diamond Minecart, for example. And administrators, this isn't just for your front end, but often people deploy this first on the back end. Because yes, one person's account gets hacked. Okay, so they've lost their sword. Your back end gets hacked, your administrator's route into the system is compromised, people are working remote, people are working from home, you expose all sorts of administrative interfaces beyond the physical office where you may develop your product, and that can take out the entire system. People can take entire databases, they can take out entire accounts. So protecting all of that is very important. But again, with this new push-style notification, you can really migrate this capability into anything that's happening inside your application, any transaction. So you're protecting worlds, economy trades, in-game purchases, real dollars being spent inside your game. Now, Apple and Microsoft do provide some capabilities here, but they're all unique to their platforms. This is giving you a common mechanism to authorize any type of activity, a purchase, a trade, inside your application with a really, really easy-to-use and simple UI. You might be a really good developer sat there right now going, give me the 3D printer, I could build this in a couple of sprints. But I do spend a lot of time working with the engineering team, and it is not straightforward to build this. So let me just give you a quick idea of what's involved if you were to go build this yourself. So first of all, you absolutely own the login logic, the 2FA logic, and the profile logic inside your application. And what I mean by that is, profile logic is most people don't want to enforce this. They want this to be an opt-in. If you want to increase the security on your account, switch this on. So that's the profile logic. It's providing a UI for somebody to go switch on and then verify that they're set up and 2FA is then working. The login logic is saying, hey, this person logs in, they've set up 2FA, let me take them through that step. This is all stuff you want control over. You don't want our product or any solution to sit in front of your application and not allow you to have that control over what's going on. So you want to own that. But by doing this, you also own other stuff. So if you're going to do this push notification, you have to write that code. So you build a library to do the push. Then to get to the device, you've got to say, well, is this user using an Android phone or an iOS phone or both? Well, let me send those notifications via the network. So Apple and Google provide you with a network for communications, and Microsoft as well. I just didn't put it on the chart. You then have to write the functionality on an app. So communicating from there to your app and back again has to be done securely, and you have to have a callback. Because this is something people will attack. People will denial of service this. People will try and penetrate this. We spend a lot of time in our service looking at how our service works, doing penetration testing, the companies that use our platform, companies like VMware, they don't mess about, right? They're not going to give us the ability to put our software into their massive cloud identity platform without us complying to all sorts of regulations and all sorts of security requirements about the service. So we spend a lot of effort in making sure that this communication into and out of the service to the devices is very secure. Hit the right button. And as I said, push is great, but you've got to fall back. You've got to fall back to what we call a one-time password, which is that code that's being generated cryptographically on the device. And how do you get that code to the end user? Well, you write software that sits on a phone that displays it, or you text it to them or give them a call and speak it to them down the phone. Now you've got to build all that functionality. You've got to figure out who's going to give you the capability, and Twilio is a fantastic company you could use for sending SMSs and voices, but you've still got to devise and design all that software. Then you've got to monitor, maintain, and security test the whole thing. There's a lot involved here. And finally, end users. The worst part of this whole thing is end users, because they lose their phone. If I don't have my phone, that is the thing that I use to log in, I cannot get into my service. Gaming is important, but we have customers like Coinbase and Bitcoin companies, and if you can't get into your Bitcoin account, you cannot get your money, and that really upsets people. So we have really good processes for supporting people who've lost devices and screwed up their configuration. And we also make sure it's legitimate. What you don't want to do is have fraudulent activity coming through your support saying, oh yeah, I lost my phone, here's my new number, can you just change it for me? Aha! Now I've got the text to allow me to log into that person's account after I got the username and password, and hey presto, all that wonderful technology on the left is circumvented by an easy attack through social engineering to your support teams. So, there's a lot involved, and you own all of this. More detail, if any of you is really interested in going to a lot of detail on this, or if you think, I want to do this, but I know my boss is going to say, I'm not going to buy this, I already pay you to develop a product, go build it. There's a white paper, this URL. You don't have to remember the URL. If you just go to authy.com, click on resources, it's easy to find. But we went into a lot of detail on each of the aspects behind building it and why you're probably better off buying it from a company like ourselves. So let's go back. So I work for a company that builds this for you. You want to own the application and that logic. We manage everything else. The cloud service, we provide you with the SDKs, we provide you with the apps, all of that functionality, and we'll do the testing, the monitoring, and we'll actually support your users for you for changing phones, etc. And you just talk to us. So I said this was easy as 1, 2, 3. What I mean by that, first of all, to do this with us, there are 3 methods that you're calling to us. There is logic around these, and we'll look at the code in a second. First of all, you've got a registry. You need to tell us who that person is, and all of you did that when you went to demo.authy.com. So you gave me a phone number and an email address, and now I have created an account for you, ready to communicate to you to go through the login process. Once you've done that, and you're actually logging in your login logic, you need to insert that, hey, let's send an approval request. Or somebody's trading that item, send the approval request. And now we will handle this secure communication from our service down to the device to get that response to the approve-deny process. And when you respond to that, there are actually 2 ways to do it. The poor man's way of doing it is you just poll us. So you could send the approval request for Simon. Hey, Simon, someone's logging in, is it you? And then you could just sit there and say, has he done it yet? Has he done it yet? Has he done it yet? Waiting for a response. The better way to do it is just have us tell you when he's done it. So then you need to handle the callback. So when somebody does say, yes, I'm going to log in, we then come to a URL you give us and say, we send you a signed and secured packet, a bunch of JSON, I believe, which contains information about the activity that's just happened. So last slide before we get into the meat. What's actually going on in the background? So let's have a look at my video here with Minecraft. Here's the Minecraft client. It talks to the Minecraft server. This is all you, right? So your client-server process, nothing to do with me. It's logging into that server, and that server at some point, and Minecraft's fantastic, it allows me to extend the server. I jumped in and said, whoa, before you log him in, I want to go talk to Authy, and I send a push notification request. So in this environment, the user's already got an Authy 2FA enabled. Our service looks at that request and goes, yep, I know his device. We'll figure out Apple or Google. We'll send all that communication. And then as you can see, there's the device popping up. and now the user's involved. So you've got 4 components. You've got your client to your service. That client might be a browser talking to your website. It might be your game talking to your back-end systems, but there's some sort of communication there with the user identity. You talk to us to say, hey, I want this guy's authentication to be more secure, or the trade to be approved. We'll communicate with the device, and then all the way back again. So they hit the phone, they talk to us. We will then talk down to your application via that callback and say, this is what's happened, and if you're successful, you're logged into the game. Okay? So just giving you that flow, just in case any of you are lost in callbacks and code and what's going on, that is how this works. And again, those 3 calls are really all you're doing with us. You're registering the user, you're sending that request, and you're waiting to get the message back. Right, enough already. Let's get out of slides and into some code. So how are we doing for time? We started at, oh yeah, good. We started at 10. Right, so let's go through this nice and slowly. So so what I'm going to do, so first of all, I'm actually going to go shut this web service down now. So demo.authly.com is about to go offline. So if you haven't signed up, I'm sorry. I gave you plenty of notice at the start. Sounds mean. And it's a Node.js server, and that's just gone offline. Right, so now I'm going to jump into the code. The code's actually running on a remote server, and if I look at this via Vi or Nano, it's going to look pretty ugly. So actually what I'm going to do is walk through the code inside my development environment, because it's pretty and it's got colors, and I'll kind of just point out where the 2FA in that site's been added, and then I'm going to jump over and quickly uncomment the pieces that I've actually already deployed to the server itself. But let's get into the detail here. So first of all, let's jump to the file. Right, so everybody in this room that's signed up to the site has already gone through this particular process, which is the addition of a user. So when you hit submit on that form posted to our server, and it ran this function add user, and it collected your email and phone. And the first thing I did then was call Authy register user. So we have helper libraries for Node.js, Ruby, C#, Java, Python. Ooh, my memory is, yeah. So we've pretty much got libraries for the majority of services you're going to use on the back end. On the mobile side, we have an SDK for both iOS and Android, which allow you to customize that whole UI. But in this instance here, I'm using the Node.js library, calling register user, and all I'm passing in there is the phone and the email address. And I get back from that a unique identifier from Authy. So this identifier you need to keep. That's really important, because we don't want to store lots and lots of information about the end user. We need the phone number, because if they can't log in using a certain mechanism, they may want to get a code over SMS or get a phone call. And their email address is how we're tracking that account. And also, the email address is very useful for us. If they're coming to us to say, hey, I've changed my phone number, we use that as part of the communication so that we can make sure it's not fraudulent activity. So we need those 2 pieces of information, but we don't want to catch anything else. So we give you back an ID that says, for that user you've just spoke to us, here's the identifier. And you have to save that. So if you look here, I'm saving that Authy ID in the response from that call that I made to the function. So it comes back this ID, and I stuff that in the database. So I now have all my user information, and I have a new piece of data inside that database table, which is the Authy ID that came back from my registered user. Really, really easy. There's nothing complicated in that at all. So now I've registered a user. Now what I want to do is, as part of the login, I actually want to evaluate, do I take them through the 2FA step? So in this example, I'm using, I'm using some client-side functionality. I'm using sockets to hook the client request to the back end. And I'm actually using the clients to post the logon data to the service itself. So the form on the website, which we'll see in a second, actually you'll see when you're logging yourself, when you hit that form, you're going to put in your email address, and you're going to put in your password, which is 123456. So remember that. I've set your password for you. Don't worry about that. Once I've unhooked this, it's then going to display a modal dialog, and this modal dialog is what kicks off the whole process. So here you can see at the moment the site is just going to log you in, and that's just evaluating your username and password. But what you want to do in the real world when you're deploying this is you want, first of all, want to evaluate, well, has this person set up 2FA? So as I said, for demo.authly.com, I forced it on everybody. So I know that's already been set up, so really this logic is superfluous, but it helps me demonstrate the point. Because most people today will want to opt into it. And this is a decision that you have to make yourselves. So Twitch deployed this, and they were like, do we want to force every single user to go through this hoop? Does every single user have an app on the phone that we can send a push notification to? So they decided, actually, we're going to educate users and allow them to come and switch it on. And I think the state of education today for the general populace, that's probably for the majority of users the right decision. Some companies' users that handle a lot of financial information, tax information, they force this on you, right? So Coinbase, you have to set up 2FA. Why? Because your username and password is a horrible way to protect your Bitcoin. Because Bitcoin, as anybody that's familiar with that type of currency, once you've got it, you've got it. Right? It's not like Wells Fargo could say, oh yeah, don't worry, we'll deny those Visa requests. Bitcoin is a lot more sensitive to abuse. So here what I just have is very simple logic. So when I registered a user, I'm pulling back from the object in the database to say, has the Authy ID been set? If it has, I want them to go through a specific process for 2FA. If not, just log them in and let's hope that it's really them. So in the Authy specific process, jump here, I have another controller, and that fires up a modal dialog that you're all going to see on your phones in about 5 minutes. And as that launches, passing into it is this one-touch request here. So I've registered a user. The next step in the easiest 1, 2, 3 is sending that request down to your devices. So as well as registering on demo.authie.com, you need to have the app on your phone because that's how I'm going to talk to you from the website to your device. And that send one-touch request here, it's from the client side. It's posting to, on the server, an endpoint to send that request. So let's go jump on the server side. Oops. Mouse fingers, so where are we? Send one touch, there we go. So there is the second method that I was talking about. So yes, there is, I say it's easy as 1, 2, 3, 3 methods. Of course, there is logic around this that you're evaluating, you're instantiating variables, you're grabbing data about the request. But what I'm doing here is I'm highlighting the very specific times where you actually talk to our service. So in this instance, the modal dialog has appeared. I have information about the user. You've already you've typed in your email address and password. I look up your Authy ID from your email address, and I'm now posting that to our service. And there's a bunch of stuff in the method there, but essentially, this is the user I care about. And then in there, I'm sending some details and a logo. So I'm saying, display this picture when they get the request, and display this data. You're logging in, or someone is trying to buy your sword or something of that nature. So you can customize that communication. Again, if you're sending that to our app, the UI is fixed. You can customize what's in it. If you have used the SDK, you basically get the request, you get an object, and you display that however you wish. So that line here generates the call down to the device, and we handle everything from there on out. Now the phone is sat there with a request and waiting for the user to respond. And when the user responds, there is a callback. If I go down here, so I have configured in Authy. So when you work with Authy, you go to our website, you create an account, you create an app, and you point that app back to your service. And here is my endpoint, which will receive the callbacks that come back in. And that callback come back, essentially there's logic here, and what that does, I won't show it in detail, it uses sockets to say, hey, remember that guy who's sitting there at the website waiting for some response? Go send an approval back to that, and then get rid of the dialogue, and then continue their login. And you can do other things at that point. They might be sat there waiting for this thing to happen. If it's in-game, you have a process sat there waiting for something to happen. It's just sat either in a slow loop or something of that nature. And you can communicate, denied, for example. Denied, you can't get into that room. Denied, sorry, the trade didn't happen. So you have that callback ability to make decisions based on what happened. And the two responses you're getting are approved or denied. And then there is obviously the state of pending or expired. So you might actually send these things out and the guy never responds to it. So if you never get a call back, you might actually want to poll our service and say, hey, what happened here? I've been waiting for this call back. And you get back saying, well, the message expired. So maybe the person that was logging in wasn't really that person, and the other person's fast asleep and their phone is by their bed. So again, we provide you with lots of kind of statuses around what's going on in that authentication process. Yeah, whenever I get to this bit, I'm always surprised how simple it is, right? So register a user, send a notification, wait for it to come back, and then do something about it. Really, really straightforward. Okay, now the meat. Is everybody ready? Yeah? No? Yes? Arms in the air? Who's ready to do this? Okay, all right. So I'm going to get into the server, go modify the code, and then as soon as I start that server up, you're going to go to demo.authie.com. You're going to hit the login page, or go, if you want to do it faster, demo.authie.com/login. You're going to type in your email address and the password 123456. You're going to see a little dialog pop up. Your phone's going to beep. And if you've got good network connectivity, now that comes over IP. So you either connect to the Wi-Fi or you're connected to your local telco provider. I don't know which one's faster. You make that, this is all a competition. You've got to figure out which you think is the fastest route. That request is going to come down to your phone. You hit approve. That's going to notify and come back to my web service. And my web service, as we're about to see, has some logic in there, which, oops, I'm in the wrong folder. Where am I? All right. And that web service is going to see the first person that comes through that, populates global variable, and I'm going to get an email. So let me get my phone ready so I can see this. And this is where I start shaking because this might not work. I really hope it does. So we go. Okay, so here's those comments that I had earlier. The server is not running, so don't try and hit it now. Let's go. And what I'm doing here is I'm saying, if somebody's logging in and they've got 2FA set up, which we know you have, we're going to go through the Authy. So that Authy thing there generates the dialog and generates the request. So I'll save that out. Now I need to deal with it on the back end. So that was my client-side logic. Now I'm going to modify my server-side logic. And there's two places in here. One is, where are we? There we are. So this one is detecting who the winner is. So like I say, I have a global variable which is looking for that. So it's going to populate winner with an email. When I start the server, it's blank. So the first person that gets through there, I'm going to get that email right there saying, this is the guy that won, and this is his email address. You will see on your phone, the website on your phone will tell you if you've won, and it will tell you if you haven't. So I want to see the hand in the air, whoever successfully does this. Remember, Authy, hands off. And I've commented out the redirect there, so it responds correctly. And then the final piece is, where's the final piece? Oh, I thought there was two things I needed to do. Actually, I believe it might be my client-side code. Sorry about this. I'm still remembering what I did. There we go. Right, so on the client side, sorry, it's part of the login. If you do this, so this is the handler or the specific function. If you do get past the 2FA, depending on the back end. So the back end will identify who's won. It's going to post that back, and you both go to different websites. So you want to get to /winner. You don't want to go to /sorry. Okay. All right. So I have to jump to root because I'm listening on port 80. Authy demo. PM2 start. Ready? Great question. What's the default password? Didn't that just show a great example of why they're horrible? 1, 2, 3, 4, 5, 6. Got it? Okay, good question. I mean, a lot of people are probably sat there thinking, oh, what did he say? I hope somebody asked that question. Yeah. All right, so now it takes a couple of seconds to start up. It's got to do a database connection. It's got to instantiate a few things. So, all right, now I have my mail here. Have I got everything ready? I think I have. 3D printer. You ready? Go. All right, it's up. I catch my mail. I can't see anybody in the room. This light is very strong, so let's see what happens. I'm checking it. And I'm using Mailgun, so there's delay in the mail getting to me as well. Anybody doing it yet? Sorry? Oh, don't tell me it's not working for you. Please do not. Oh, no, I've got one. You must have fat-fingered it. Damon. This guy here. Oh, awesome. Right. Whew. Okay, right, well, thank you very much. And for those of you who are, so first of all, the gentleman with the invalid credentials, it was 123456. Damon proved that, I mean, you didn't have to choose your password, so you might have fat-fingered your email. I apologize. You're probably looking at a sorry, tough. I'll give out free t-shirts, right? So I'm going to nip back to the office now. I forgot to bring them in. Everybody gets a t-shirt if you're interested in one. It's got our code on here. But Damon, thanks very much. Come up and talk to me after this. So finally, let's just go back to my prayers because we do have 10 minutes left. Does anybody want to ask me any questions about this? So I'm obviously clearly technical enough to go through the code. If the lady at the back, could you just raise the light a little bit so I can kind of see the room? Hey, oh, she was listening to some music. Oh, a gentleman there. Yeah, these lights are killing me, man. Could you raise the lights a little bit for me, please, so I can see the room? I can't. What was your name, sir?
George.
Hey, George, how you doing?
Hey, nice presentation. I'm
Thank
good.
you.
I was curious, how bad an idea is it to use this as single-factor authentication instead of a password?
Right, I nearly actually did that for the demo. I thought, you know what, let's get rid of the password. You could do that. So George's question is, if I could do this, if I could communicate with a device that I trust, why do I even need the password? Actually, you don't. So go to Yahoo, do a search for Yahoo account key, if anybody here uses Yahoo Mail or Yahoo service. They have built essentially what you can build with us, except you can't buy it from them. You can't use theirs. It's proprietary. So the process for doing this as first factor is you need still to register that device. So you're not getting rid of the password per se. You're just using it to trust an initial registration for subsequent logins that don't need a password. So what Yahoo do is you install their app, you authenticate to the app with your username and password, and you switch on this capability. The next time you go to Yahoo's website and you type in your account name, it does a jQuery looks it up in the database and goes, oh, actually, you've already got this thing set up. I don't need your password. And it just beeps your phone, and your phone goes beep. You hit approve, and they have exactly the same idea. Call back, and it logs in. So yeah, absolutely, you could use this to totally replace the use of a password for consistent logins.
Cool. Thank you.
Sure. Hello, what's your name?
Hi, Nihav Jain.
Hey, Nihav, how are you doing?
Yeah, hi, yeah, I'm good. Great presentation, first of all. So have you, do you save any kind of data, user-related data, via your mobile app, as on the device itself?
Do we save any user data on the mobile app itself?
Yeah.
Not really, not other than I would hook my phone up and show the app so I can show some of the details. We're storing phone number and email inside the app because we're using that as part of the communication, and we're storing that Authy ID. We do have the tokens which we're displaying. Now they're cryptographically, protected, and obviously it's inside an app which is containerized as part of the iOS or Android platform. So we are storing some of that information locally. We can actually, so one capability with the fear, if you're looking at what should I be concerned about with what's being stored on the device, is we do store those tokens, and we have a secure mechanism to retrieve them. But you always have to be wary of that information residing on that device. Now we support multiple devices, so if you were to, we have a Chrome plugin as well, which presents the data through Chrome. So I have two Chrome apps. I have an iPad and an iPhone on my account. If my iPhone gets stolen, and I was foolish enough not to have any PIN on it, and you could basically get into the app and fire the app up, I could quickly go to my desktop and say, oh, I start Chrome, and I go, oh, my phone's gone, delete. We are no longer going to trust that application. Because when the app fires up, we always make a call to our service, say, hey, is this a trusted application? And you can remove those. So we store as little information as possible to do our job, and then we have mechanisms to allow the end user, and I would have to double check. I think you may also have the ability to remove those devices programmatically via the service. I'm not quite sure about that. That'd be a great feature request if we don't.
Okay. So basically, the app is also protected against, like, if the device is jailbroken or rooted in for Android, then even if someone has access to the Authy ID and basically all the local data which is stored on the phone, the end client can still deny him.
I have to admit, as much as I'm more technical on the server side, how the API and the database works. I'm not too sure if our app was on a rooted device, what the correct response to that would be. So I don't know quite now. I don't want to give you some bullshit answer and say, oh yeah, it's fine. I'd rather give you the accurate answer. Okay. So you're willing to email me, so sthorpe@tweeter.com, and I can specifically get that back. Sure. My experience doesn't deep that far into the client.
Okay, thank you.
Thank you. I love those tough questions. All right, anybody else? Okay. Well, enjoy the rest of the show. Thank you very much. I appreciate you coming.